Hello. In this video, we're going to be taking a look at a couple of polynomial functions to find where they are increasing and decreasing. So let's jump right in. Our first one, our function is 2.3 plus 5.8x minus 1.4x squared. So the first thing we need to do in order to determine where this function is increasing or decreasing is to find the critical values. That is going to be where our derivative is either equal to 0 or undefined. So we need to find our derivative, and the derivative of 2.3 is 0, the derivative of 5.8x is 5.8, and the derivative of 1.4x squared, we've got a minus there, so that'll be a negative 2.8x. All right, this function is never undefined. So we don't have any critical values that come from where it's undefined. It is equal to 0 when, let's see, we'll add 2.8x to both sides and divide both sides by 2.8. Let's go ahead and get the calculator. 5.8 divided by 2.8. Now that's not a decimal I recognize, so let's do math, enter. That is 29/14. So that's going to be our critical value, our only critical value. So now we're going to make a table, and we would use the domain of the function if this were an application problem or something like that, but this one there wasn't anything given, so our domain is going to be all real numbers. We're going to label our critical value 29/14, and remember that is approximately 2.07. So we can use that to help us find values on each side. If you have more than one critical value, all you need to do is make sure that they are in numerical order whenever you put them on the number line. All right, so now we're going to pick a point. It does not matter. Anything to the left of that one, probably the easiest point that I can think of to try is x equals 0, and we're going to plug that x equals 0 into our derivative function. So our derivative at 0, if we plug in x equals 0, we get 5.8. Since that is positive, that means that our function is increasing on that interval. So I'm going to draw an arrow that's going up and to the right, meaning that it's increasing on that part of the graph. And then we're going to do the same thing with a point that is on the other side of our critical value. Remember, this was approximately 2.07, so we just need to pick a number that's bigger than that. I'm going to go ahead and pick 3. And again, we're plugging it into that derivative. So f prime of 3, if we plug 3 in for x, we get 5.8 minus 2.8 times 3, which is negative 2.6. That negative 2.6 tells us, the fact that it's negative is telling us that our function is decreasing. That means that our graph is going down and to the right. So that means our answer, our function is increasing on the interval. Here it's going to go all the way to that arrow, so that means negative infinity, all the way up to our critical point here, which is 29/14. We are going to use a parenthesis on that point, and it is decreasing from that point, 29/14, all the way to positive infinity. One thing that you can double check is these will not overlap. And together they should make up the entire domain of the function. All right, now let's look at the function f of x equals negative 4x minus 11. So we're going to start out the same way. We're going to take the derivative. The derivative of negative 4x minus 11 is negative 4. Well, that's a constant function. that means that our derivative is constant. So, doesn't matter what x value we're looking at, our slope is always negative 4. And if you think of the graph of y equal negative 4x minus 11, that is a graph that is decreasing because it has a negative slope. So there are no critical values because it's never equal to 0 and never undefined. And so technically, if we put it on a number line, we don't have anything there. We pick any test value and we get that f prime at that number. Well, it's equal to negative 4 everywhere, so it's equal to negative 4. That means this function is always decreasing, or it is decreasing from negative infinity to infinity. All right, I'll see you guys next time.